In this learning objective now, let's take a look at three theories of term structure. So up until now, we have been assuming that the interest rates, let that be, let's say, spot rates or the yield to maturities, we've been assuming that they are flat, which means that there is the same rate that is applicable for all tenors or maturities. In reality, what we observe is that interest rates are not flat, I should say. Okay, interest rates do have a term structure to them, which means that there is a different interest rate for a different tenor or maturity. Now, these term structures, they exhibit certain behaviors. These are, commonly accepted or, normal behaviors. You can actually list them. Let's say, usually speaking, we observe that term structures of interest rates are rising, which means that long-term rates are generally higher than short-term rates. Another aspect which we observe about term structures is that, generally speaking, rates of different maturities or tenors move in the same direction, which means if short-term rates go up, they are generally, associated with long-term rates also going up. Okay, so in general, the direction of movement is roughly the same. So these are various behaviors that we see about the term structure, and what we are aiming here is to basically try and put forth various theories that can explain the commonly observed behaviors of term structures of interest rates. So let's do that. Let's begin with the first theory. This first theory is what we refer to as the expectations theory. Now, what I'll do here is that for each of the three theories that we are about to do, we will always start with the key assumption which these theories are making. So the key assumption in the expectations theory is that investors in bonds, and here I'm comparing bonds with different maturities, are pretty indifferent in terms of which bond to invest in. So we can state this assumption as bonds with different maturities act like perfect substitutes for one another. That means you have no preference. You as an investor have no preference as to whether to invest in short-term bonds or in long-term bonds. Both these bonds are believed to offer you, let's say, the same holding period return over the upcoming period, for example. Okay. Now, to get this working, to get this assumption working, let's try and see, this assumption in a very simple context. So I'm assuming here a 2-period horizon. In this 2-period horizon, I'm saying that the investors do, let's say, believe in this assumption, and that is bonds with different maturities are equivalent. They are perfect substitutes. And therefore, standing at point or time t equal to 0, I as an investor will be indifferent between, let's say, investing in a 2-period bond. Here I'm assuming each period is 1 year. So let me restate it. I as an investor, I'm indifferent between investing in a 2-year bond versus investing in a 1-year bond and then rolling over my investment into another 1-year bond. Okay, so this is my strategy 1. That means investing in a 1-year bond and then rolling it over. And my strategy 2 is to invest in a 2-year bond. Okay. Now, to make things even simpler, let's treat these not as bonds, but let's say as loans. So let me give you some data. So let's say as of time t equal to 0, I am served with 2 interest rates. There is a rate R01 and there is a rate R02. Let me first tell you what is the nomenclature I am following. R01, think of it to be the lending/borrowing rate that is fixed as of today, and that's why the first subscript is 0, and is the lending/borrowing rate for the upcoming 1-year period, and that's why there is a 1 here. Now, this becomes self-explanatory now. It basically means the rate which is fixed today for a lending/borrowing that happens for a period of 2 years starting from today. Now, if I were to, let's say, enter into strategy 1 in which I, let's say, invest $1 into a 1-year deposit, for example, okay, then when it's time to actually roll over this receipts of this 1-year lending, for example, into do a lending which is from t equal to 1 to t equal to 2, then the problem here is that I do not know what sort of 1 year rate will be prevailing at time t equal to 1. The only point in time I'll get to know what this rate is when I finally arrive at time t equal to 1. Before that, I do not know what this rate R11 is. And you will appreciate the nomenclature here. It's the rate which is set at time t equal to 1 for the upcoming 1 year. And that's why it's written as R11. I'm assuming here that these rates are continuously compounded. Therefore, in strategy 1, you will land up with a final payoff that looks like start with $1. This $1 grows at this rate R01, which is a continuously compounded rate, and hence the capitalization factor is e to the power of this rate, this times a 1 because it's 1 year, and this times another capitalization factor which is from time t equal to 1 to time t equal to 2. But this happens at that rate R11, which I do not know yet. Now this is my final payoff of investing $1 into this deposit account and rolling it at time t equal to 1. The other strategy was investing or lending this $1 at a 2-year rate, and that rate is R02. That means it will grow for 2 years, and since this rate R02 is an annual number, I need to do e to the power R02 times 2. Now, come back to my assumption. I was making this assumption that I, as an investor, am indifferent between these two choices. So if I'm indifferent between these two choices, it means the payoff of both these choices should be equal when I finally arrive at time t equal to 2, which tells me that this guy is equal to, just add the exponents, so it will be R01 plus R11, and this guy is e to the power 2 R02. So if the two are equal, that means the powers are equal, and which means that there is a relationship which should connect the three rates which we are talking about. The spot rate as of today for 2 years, the spot rate as of today for 1 year, the rate which prevails from 1 year onwards for the upcoming 1 year, these are connected using this equation, if this assumption were indeed to be true. Now, I told you that this R11 is a random rate. I do not know what this rate will be unless and until I arrive on that day. R02 and R01 are actually known to me. So therefore, this equation, ideally speaking, it should be written something like this. And that is, the spot rate for 2 years as of today is equal to the average of the 1 year spot rate and the expected 1 year spot rate 1 year from today. So my spot rate for 2 years is the average of these two rates. Okay. Now, what can I do? I can actually extend this logic not just for 2 period analysis, but rather I can extend this for any number of periods chained together. So let's say I write down this expression for the case of a t-year spot rate. So extending my verbal conclusion which I just drew, I can say that the t-year spot rate is the average of the 1 period spot rates. Here, the first one is known to me, and for all the future 1 period spot rates, I am using their expectations. So I am saying that the t-year spot rate is equal to the average of short-term rates that prevail from today till, let's say, t-1, because t-1 is the last time at which I notice or observe any rate which will affect me. Okay, so these numerator, it has t terms in it, and you're dividing by t. That's like a simple average. Now, if you remember the readings that we did on forward rates, right? When we were exploring this concept of spot versus forward rates, we had actually used the same logic then also. We had said that forward rate is that rate which makes me sort of indifferent between lending long term versus lending short term and then rolling over my lending at the prevailing rate. So that was the same logic that we had used then. Okay, but here we are saying that we are starting with this assumption that investors are indeed sort of indifferent between bonds of various maturities. So since our logic is the same, And since we are arriving at a very similar kind of conclusion, and that is the spot rate is like an average of short-term spot rates, first of them known, the future, the other ones are expected values, I can actually draw this link, and that is the expected rate, the 1 year rate, let's say, T periods from today is the same as the forward rate that you observe as of today and prevailing between times t and t plus 1. This is another way people remember the expectations theory. I mean the statement of the expectations theory. And it says that the expected short-term rates in future, the best predictor or the best guess of these short-term rates in future are the forward rates that you observe as of today. Okay, that means if I were to draw a diagram, then if I am standing as of time t equal to 0 and I am trying to figure out what will be the expected short-term rate, and here I am saying short-term is 1 year at a future time t, I am saying this rate, the best predictor of it would be to just find the forward rate in between this time slice, that is between t and t plus 1, and that forward rate is my best predictor for the expected short-term rate when I finally arrive at time t, because that's when I will finally observe that rate. Okay, this is another equivalent statement of the expectations theory. Now let's take a look at how this expectations theory helps us explain the shape of the yield curve. So if you observe that the yield curve is upward sloping, or equivalently, let me say, if you observe that the spot rates are upward sloping, what does it mean? It means that the 2-year rate will be higher than the 1-year rate. That's what it means. Then if you were to get it back to this definition of yours, which we've arrived at, if R02 is higher than R01, that can only happen if this second guy is higher than the first guy. Because only when this guy is higher and I take an average of the first and the second guy, I'll get a rate I get an average, I should say, which is higher than the first term. Okay, so this means that, or this observation means that the expected value of the short-term rate is higher than, let's say, the current value of the short-term rate, which is to say that, verbally speaking, investors expect the short-term rates to go up in future. So therefore, I can write down this statement as, when you observe a rising term structure of spot rates, then it means that the investors are expecting short-term rates to rise in future, and that is why your spot rate term structure is upward sloping. A similar reasoning would apply for the case where your spot rates or yield curves are downward sloping, and that will be the case when the expected rates are going to go down in future. Investors expect rates to go down. Okay, now this was about the expectations theory. It basically told us that long-term rates are basically averages of short-term rates, what you observe today, and their expected values going forward. Now, this expectations theory has a drawback, and that is, since expectations can go either way, this theory will not be able to explain to us why yield curves are usually rising. Why are they upward sloping usually? If expectations can really go either ways, they can go up or they can go down, why are the observed yield curves, generally speaking, upward sloping? So that's a drawback of my expectations theory. Now let's do this. Let's move on to another theory and let's see if that theory can help us provide an answer. And that is what we call the market segmentation theory. Now this theory makes an assumption which is actually stark opposite to the assumption which the expectations theory made. And that assumption is that bonds of different maturities are actually they are not substitutes of each other. In the first expectations theory, we said they are perfect substitutes. It doesn't matter which bond you pick. In the end, all bonds are going to give you the same holding period return, at least for the first period, for example. Okay, and even stretching it to the full horizon, they are going to give you the same holding period return. That's what the expectations theory told us. But here, the market segmentation theory says no. Bonds of different maturities are not substitutes of each other. So investors, what they do is they try and park themselves in a certain segment in terms of maturities, depending on, let's say, their liabilities or depending on their needs. So if you would want your money back early, you would want to place yourself in bonds which redeem or mature early. If you want to, let's say, have money for sponsoring, let's say, a liability which comes really in the future, for example, your child's education, you would want to place yourself in long-term bonds. So that preference for bonds, it comes from your basic, liability structure, your needs, and depending on those, you place yourself in one of these maturity segments or market segments. Once you are in these segments, you don't hop over and skip over from one segment to another. If that doesn't happen, it means that any fluctuations in interest rates in any one segment will not impact the interest rates in other segments, because investors don't hop over from one segment to another. Okay, so therefore, if I have to determine, let's say, the short-term rates, intermediate term rates, and long-term rates, I will independently determine these rates as, let's say, the intersection of demand and supply in each of these segments. Okay, so each of these segments would have their own interplay of demand and supply forces, and each of these segments therefore independently produce a separate rate. To the extent that it can produce a term structure of interest rates that is very discontinuous. It may no longer be a very smooth curve like this. It can be a very discontinuous curve as well. Okay, now, can this theory explain the fact that yield curves are usually upward sloping? Yes, it can. How? Because investors, they would want to, in general, place themselves in buckets which are not too long dated in nature. There will be a higher propensity for investors to, let's say, place themselves in short-term buckets, a few in long-term, intermediate term, and actually a lot few investors finally get to choose the long term. Okay, so if that happens, what are we doing? We are increasing, let's say, the supply of funds, because I'm talking about an investor who is here to lend. Okay, we are increasing the supply of funds in short dated buckets or short dated segments, and because of the increased supply of funds, we are pushing down the interest rates. Okay, and therefore you will see an upward sloping term structure of rates. Okay, so market segmentation theory, it says that you have very strong silos in which investors operate. Each of these silos, from its own intersection of demand and supply curves, produces a separate rate, and it's able to explain why yield curves are upward sloping. Now let's do this. Let's move to another theory, and this theory is what we call the liquidity premium theory. Now, the drawback of market segmentation theory was that it really takes things to an extreme. It says that these rates, short term, intermediate term, and long term, do not affect each other in any way, because these silos are are categories or segments from which investors don't hop from one to the other, and hence any short term rate does not affect the long term rate. Now that is something which is a bit hard to digest, and therefore let's move on to a theory which can still help us explain this, but doesn't make this strong an assumption. So this liquidity preference or premium theory is a theory which makes an assumption which is like midway between the two assumptions that we've made till now, and that is the bonds of different maturities are imperfect substitutes of one another. Remember, the first theory, it made this assumption that they are perfect substitutes. Second theory, not at all, no substitutes. And the third theory is striking a middle ground. It's saying, let us assume that bonds are imperfect substitutes of each other when it comes to different maturities. So if that were to be the case, then we are talking about a spot rate which is determined both by, let's say, an average of a number of short-term rates, the way our expectations theory, made this connection between long-term spot rates and short-term rates, plus it's saying, let's also include a certain risk premium. Why is that the case? Because if you go back and remember the two strategies which we talked about, the strategy of a 2-year lending versus a 1-year lending that is, let's say, rolled over into a second 1-year lending, then the guy who is doing this lending is actually facing a risk. And the risk is that this guy doesn't know what interest rate will prevail here. Okay, so this risk is being taken up by the guy who invests for a 2-year period with one rollover in between, and this risk is not taken up by the guy who invests in only one period. Okay, so the guy who's making a 2-period investment with one rollover would want to be compensated for this risk. Okay, we've done this concept of duration. We know that longer is the duration, higher is the interest rate risk, and that's what we are saying here. We are saying that longer is the tenor of the rate that we are talking about. Longer would be, or bigger would be the duration, and more would be the interest rate risk, which a guy who is planning to invest for T years with, let's say, periodic rollovers will be exposed to. So if you are working out the fair rate that should be paid to this guy for, let's say, one hop from today till time T, that fair rate should take into account the risk which this guy faces had he been doing this periodic rollovers. Okay, so that's the connection which I want you to make here. I'm trying to work out the rate for one big hop that is fair to the guy who was trying to replicate this rate by smaller hops. And I'm saying, barring the first hop, the future hops carry risk in them. And because the future hops carry a risk, I need to compensate for that risk by providing this guy with a risk premium. This risk premium, let it be a positive number, and this risk premium, let it be a function of how many hops you are making. Okay, so more are the number of hops, let me give you more reward for bearing that risk. Okay, so this is my liquidity premium theory. So this theory, it will try and explain quite well actually how and why yield curves are rising in nature. Why do yield curves why are they upward sloping? And we are saying that it's because the long-term rates, they are both derived from an average of short-term rates plus a factor which has this propensity to lift rates upwards, and that is this factor of interest rate risk. Okay, and therefore even if your rate expectations are flat, that means investors believe that rates will not go up going forward, they will stay the same as what they are today, still this presence of the risk premium will lift the rates term structure up. Okay, so what we've done here is that we have taken a comparative look at 3 theories of term structures: expectations theory, market segmentation theory, and liquidity premium theory. Each one of these has a different key assumption which they make, and each one of these has a different way of explaining, let's say, the shape of the the interest rate term structure.